So the topic of this paper is detecting outliers. Do not use standard deviation around the mean, use absolute deviation around the mean. And here are the authors. So the aim of this paper is to outline the median absolute deviation, from MAD method, as a way of dealing with the problem of outliers and highlighting the problem with mean plus or minus 3 standard deviation method for outlier detection. So it is basically introducing a new method, MAD, and highlighting problems with using standard deviation, mean plus minus 3 standard deviation method for outlier detection. Next. So we'll talk a little about the mean plus minus 3 standard deviation method. This method is based on the characteristics of a normal distribution for which 99.87% of the data appear within the range. 99.87 data is between mean plus minus 3 standard deviation. Therefore, 0.13% of all cases are marked as outliers, meaning they are outside the range. Unfortunately, 3 problems can be identified when using the mean as a central tendency indicator. Firstly, it assumes that the distribution is normal, right? Outliers included. But that may not be always the case. We may have to detect the outliers in a distribution that is not normal. Secondly, the mean and standard deviation are strongly impacted by outliers. We are trying to detect the outliers using mean and standard deviation, but they themselves are heavily impacted by outliers. Thirdly, this method is very unlikely to detect outliers in a small samples. For small samples, this method is unlikely to work. Now we'll talk a little about calculating mean. I think it should be easy. So accordingly, this indicator is fundamentally problematic. It is supposed to guide our outlier detection, but at the same time, the indicator itself is altered by the presence of outlying values. In order to appreciate this fact, consider a small set of n equals to 8 observation with values 1, 3, 3, 6, 8, 10, 10 and 1000. So we have mean equals to 130.13 and uncorrected standard deviation 328.80. Therefore, using the criteria of 3 standard deviation, we could remove the values outside the range minus 856.27 and 1116.52. Nevertheless, the value 1000 is not identified as an outlier, which clearly demonstrates the limitation of mean plus minus 3 standard deviation method. Now we'll talk about an alternative suggested by this paper. It is the median absolute deviation from MAD method. The median is like the mean, a measure of central tendency, but offers the advantage of being very insensitive to presence of outliers. One indicator of this insensitivity is the breakdown point. The estimated breakdown point is the maximum proportion of observation that can be contaminated, that is set to infinity, without forcing the estimator to result in a false value. The false value can be infinite or null in some cases. For example, when a single observation has an infinite value, the mean of all observation becomes infinite. If we are taking a mean of a series and if even a single value in that series is infinite, the mean will become infinite. Hence, the mean's breakdown point is 0%. For mean to corrupt, we cannot have even one value that's set to infinity. The mean will corrupt even if one value is set to infinity. By contrast, the median value remains unchanged. The median becomes absurd only when more than 50% of the observations are infinite. You have to replace more than 50% of observation to make the median absurd, that is infinite or null in some cases. With a breakdown point of 0.5, that is the proportion will be 50%. The median is the location estimated that has the highest breakdown point. Exactly the same can be said about the median absolute deviation as the estimated. And it is understood that median is also more robust than the classical interquartile range, which has a breakdown point of 25%. To calculate the median, observations have to be sorted in ascending order to identify the mean rank of the statistical series. Meaning we have to arrange it into ascending order and then calculate the position of the middle value. So let us consider the statistical series 1, 3, 3, 6, 8, 10, 10, and 1000. The position of median can be calculated as equal to n plus 1 by 2, that is 4.5 in our example. The median is therefore between the fourth and fifth value, that is between 6 and 8. The median is right here, right? So between 6 and 8 it will be 7. Our median is 7. Let's go to the next slide. Now calculating the MAD is also straightforward, as it only involves finding the median of absolute deviation from the median. What it means is MAD is B times median of absolute value of x minus median of x. That is, we will be subtracting from each value in our series the median of the series, take absolute value of each, and then calculate the median of the resulting series, and then multiply the median with B to find out the MAD. We will see the process with numbers soon. Now here xj is the original series and mi is the median of the series. Usually B is 1.4826, a constant linked to assumption of normality of theta, disregarding the abnormality introduced by outliers. With disregard, we think if the normality is being disturbed by outliers, we'll use b equals 1.4826. If another underlying distribution is assumed, the value changes to b equals to 1 by 75th quartile. Right? Now let's look at calculating MAD with help of numbers. So the series in which the median is subtracted of each observation becomes the series of absolute values. And I mean we had the series 1, 3, 3, 6, 8, 10, 10, and we had the median 7. We are subtracting 7 from each and then calculate that, then we will have the absolute values, that is 6, 4, 4, 1, 1, 3, 3, and 993. When ranked, we obtain 1, 1, 3, 3, 4, 4, 6, and 993. The median equals 3.5, which will be multiplied by 1.4826 to find the MAD of 5.1891. And then we have to define the rejection criteria. Now, depending upon the stringency of the researcher's criteria, which should be defined and justified by the researcher, Miller, he has a paper in 1991, proposes the values of 3 very conservative, 2.5 moderately conservative, or even 2 poorly conservative. So we can have, so Miller in his paper suggests the values of for this range we have 3 here. Instead of 3 we can have 2, 2.5, and 3, depending upon the researcher's need, right? And where we have the range xi, our data lie between m plus minus 3 standard deviation, so 3 MAD. In our example, all values greater than 22.57 and all values smaller than minus 8.57 we mark as outliers and can be removed. Stated differently, we can remove the observation 1000 or series. So it was able to detect 1000 as outlier. So let's discuss the conclusion. The study showed that the method conventionally used, and that is the plus minus 3 standard deviation rule, is problematic and argued in favor of a robust alternative. This leads us to three important recommendations. In univariate statistics, the median absolute deviation is the most robust dispersion scale measure in presence of outliers according to this study, and this study recommends median plus minus 2.5 times MAD for outlier detection. Second, the threshold should be the threshold should be justified, and the justification should clearly state the concerns rather than cherry picking degree of freedom guiding the selection. That is, whether to use 3, 2, 2.5 should be justified. By default, this paper suggests a value of 2.5. Now, this study encourages researchers to report information about outliers, namely the number of outliers removed and their values. So these were the discussion in the series, and it's the end. Thank you.